The title of our project is Preparation and Characterization of Activated Carbon from Cotton Stalk for Methylene Absorption. The team members are Akshita IS and Snehal, guided by Dr. N. Vasiraja, MTech PhD, Associate Professor, Mechanical Engineering. So these are the contents present in this slide. So the introduction is the environmental pollution increases with increasing industrial developments, and the textile industry plays a vital role of polluting your water, and the major pollutants in textile industries are dyes and heavy metals. So the problem statement is methylene blue is a safe drug when the dosage level is less than 2 mg. If the dosage level is greater than 5 mg, it causes the severe anaphylaxis shock. And we have used the waste material from agriculture called cotton stalk. It's a very helpful and affordable ingredient for making the green nanoparticles, which has the high absorbing capability and have high porosities. So the literature survey, we can study the first literature as preparing the activated carbon from the rice husky fly, and the second paper is preparation of activated carbon from Prosophis zuliflora stem, and this third literature, the activated carbon is prepared from the cotton stalk using the phosphoric acid and potassium hydroxide. In the fourth paper, the activated carbon is prepared by Prosophis zuliflora. Prosophis soliflora bark. The project objective of our project is to prepare the low-cost and eco-friendly absorbent, and to identify and to show the presence of zinc chloride activated cotton stalk carbon has better absorption characteristics compared to the absence of zinc chloride carbon, to identify the optimum level of EZACC. So the methodology, first of all, collect the wood and cut into pieces, carbonization process, and then proceed to 250 micron. The sample one was here, and the zinc chloride is mixed in the ratio of 1:1 and heated at the muffle furnace at 800 degrees Celsius, and remove the excess zinc chloride, and the sample 2 was given. And the various process of EZACC were first of all preparation of methylene chloride, and then remove the methylene chloride by using the cotton stalk carbon and the zinc chloride cotton stalk carbon. After that, comparing the results. So characterization, physical characterization and the chemical characterization were done. After that, the regeneration studies were done. So these are the materials used for the process. So the process of the methods are, first of all, collect the wood and cut into pieces, let it to be dry at the hot air oven for 110 degrees Celsius and for 10 hours, and the carbonization process is held at the muffle furnace 800 degrees Celsius about 1 hour, and the impregnation process is used by zinc chloride, and the activation process is done by muffle furnace at 800 degrees Celsius about 1 hour, and after that it is cooled to room temperature. The excess zinc chloride is removed by using the distilled water, and these are the final product of cotton stalk carbon and zinc chloride activated cotton stalk carbon. The experiments or physical characterization is by semi-image, EDAX and FTIR. So this is the semi-image for without activation and with activation. And without activation there is no porosity, but with activation the pore size, the number of pores are high. And this is the image of with activation. So this is the whole size of, this is the pore size. So yeah, the length of the pore size is 8.142 micrometer, and the width is 2.1425. So the specifications of the same image is particle pore size is irregular shape, and the length, width, and energy given to the filament is 20 kV, and secondary electronic is 10 mm, and magnification of pore size is 25 K. So the EDAX cotton stalk carbon EDAX image. EDAX image shows the what are the element present in the carbon. This is for the activated carbon. In activated carbon there is a presence of zinc and chloride. The FTIR result shows that the functional groups, if the number of functional group is high, the effect of the carbon is more high. So in cotton stalk carbon there is 14 functional groups. In zinc chloride activated carbon there are 17 functional groups. So this is the chemical bonding for the FTIR functional group diagrams. And the absorption experiment is done by taking a various dosage level of CAC and EZACC with 25 ml of methylene chloride. It is put in the magnetic stirrer for a constant speed of 100 rpm, and by using filter paper the liquid is filtered. And the absorption studies is done by varying the dosage levels and the time at room temperature to taking CAC and EZACC. So this is the absorption studies of 15 mg, 20 mg, 25 mg of CAC, and these are the results of 15 mg, 20 mg, and 25 mg of zinc chloride activated carbon. So UV spectrometer analysis were done by using the wavelength of 700 to 300 nanometer. The maximum wavelength of methylene blue dye is 662 nanometer. At one peak, the graph reaches the smooth increase and then it decreases the peak, so that the peak is the maximum wavelength of the methylene blue dye. So these are the UV results from the UV spectrometer for without activation. This is for with activation. So the absorption efficiency is calculated by using the formula initial efficiency minus final divided by initial into 100. So this is the efficiency of the cotton star carbon. It will go up to 43%, but in zinc chloride activated carbon, the efficiency is up to 96%. So this is the graph for without activation and with activation for cotton star carbon. So without activation, the it is goes up to 45%, but with activation, it is 96%. So the CCD analysis were done by using ANOVA software for 15 milligram, 20 milligram, and 25 milligram by varying the time of 5 to 10, 15 minutes. So this is the formula generated from the CCD analysis. So the CCD tables were done by calculating 13 interpolate values by varying dosage and the time. The efficiency goes up to 96%. So this is the 3D plot for zinc chloride activated carbon and activated carbon. So the optimization result from the CCD analysis for cotton star carbon is in 8 minutes the carbon absorbed the 32 milligram, but in 32%, but in zinc chloride activated carbon in 14 minutes 20 milligram of dosage is absorbing the methylene plus 91%, so it is more effective. So the absorption studies with the temperature. So the previous temperatures is include the previous studies of absorption with including the varying temperatures. In this previous studies we use the room temperature, but here 45 degrees Celsius is added. And for this is the 3D surface plot of cotton star carbon, and CCD studies for time, dosage, and the temperature. The efficiency is goes up to 25% in cotton star carbon and 80% in active zinc chloride activated cotton star carbon. So these are the chemical characterization we were done for the studies: ash content, pH, solubility in water, and solubility in acid. So heavy metal absorption studies also. Iron is dominantly absorbed 93% of the heavy metal. So regeneration studies also done. After 4 consecutive cycles, the efficiency is up to 52.85%. So these are the results of regeneration process. So the conclusion was zinc chloride activated cotton star carbon was successfully applied in the removal of methylene blue dye, and SEM image, FTR, and EDOX are removed. Reuse efficiency of 52.85% also 85% after 4 consecutive cycles. So HTCC could be recommended as a low cost absorbent alternatively activated carbon in the effluent container. So these are the reference. Thank you.